try these two problems before we start our review. So number one, the angle property that we needed to remember are alternate interior angles. So when we have two parallel lines like L and M, and when it's cut by a transversal, alternate interior angles are the angles that are inside our two parallel lines, but opposite sides of the transversal, and they are equal. So that means that if this angle is 52, that means this angle is 52 degrees. Now the reason that I wanted and I needed to know that angle is because I see that angle X and that 52 degree angle are on a straight line, which means they add up to 180. So essentially my X angle plus the 52 degree angle equals 180. So to figure out what X is, I just need to subtract 52 from both sides, and I get 128 degrees for my X. For number two, we're talking about translations. So this triangle was translated so that F prime is going to land at 1, 2. So I'm going to go ahead and mark that. 1, -2. Right there is where F prime lands, which means this original F has moved. I want to know under the same translation, where would G prime be? So in order to figure this out, I first have to figure out what was the translation. So I need to count how far up, down, left, or right the F point moved to get to F prime. Well, first of all, I can see that it went down. So I'm going to go ahead and mark that. And I can see that it went to the right. So I'm just going to count down. 1, 2, 3, 4. So the translation was 4 down, 1, 2, 3. To the right 3. So the point F moved down 4 spots and to the right 3 to get to the point of F prime, 1, -2. So I want to do the exact same translation but for point G. So I'm at G, that means I'm going to move down 4, 1, 2, 3, 4, and to the right 3. 1, 2, 3. So this is going to be where G prime is, and that coordinate is going to be my X value is a +5, and my Y value is a -6. Remember for these to always use your graph paper, graph it and plot it out on your own instead of just relying on the computer. Alright, so our next transformation review is on rotations, which are always probably the trickiest. So, we always want to draw our triangle or shape on a coordinate grid. So we're given a blank piece of graph paper. I'm going to draw my X and Y axes. Make sure you're doing this at the same time. Then I just need to plot my points for F, G, and H. So F is at -1, -3. So that means I'm going to go to the left 1 and down 3. 1, 2, 3. Plot my point and label it. My next point is going to be G. So the +2 means I'm going to the right 2, 1, 2, and down 2 because it's -2. Label it. H is going to be over 2 again, but now down 4. 1, 2, 3, 4. H, and I'm going to connect them. So now I am rotating it 270 degrees counterclockwise. So counterclockwise means I'm going in the opposite direction of the way a clock would go. So I'm turning it this way. So what you need to do is we need to physically turn our paper 270 degrees, which means it's going to be 3 turns. So I'm looking for the coordinates of all of them. So that means my first turn is going to be this way, right here, so it ends up in the top left. My second turn is going to be right here, so it ends up in the bottom right. And then my third turn is going to be here, so it ends up in my top left. So when you turn your paper 3 times to the left counterclockwise, you should get your triangle to look like this pink triangle for F prime, H prime, and G prime. So the F prime coordinates are going to be 1, 2, 3 over to the left, which means it's -3, and up 1, so that means it's a +1. For G prime, it's over 2 to the left, so that's going to be a -2, and down 2, so that means it's also going to be a -2. And for H prime, it's going to be over 1, 2, 3, 4, so to the left 4, -4, and down 2, so -2. So these are my coordinates of F prime, G prime, and H prime. Anytime you have a rotation, plot your triangle or your figure and physically turn your paper the number of times. 90 degrees is once, 180 degrees is twice, and like we just did 270, we turn it 3 times. Alright, for this one we have a rectangle and it's being dilated by a scale factor of 1/3. We want to know what the perimeter of A prime, B prime, C prime, and D prime. First of all, I see the word dilate and I have scale factor. Anytime I'm given a scale factor, first of all, to dilate means to either increase or decrease in size. If I'm given a scale factor, that means I'm multiplying whatever the coordinates or whatever the size is by that scale factor. So since I just want to know the perimeter, I need to know the lengths of each side. So in my original figure, the width 1, 2, 3 is going to be 3. And this length right here, 1, 2, 3, 4, 5, 6, 7, 8, 9 is 9. So that means each side is going to be dilated, is going to be multiplied by 1/3. So then my smaller rectangle, I need to multiply each of these sides by 1/3. So 3 times 1/3, I can think of this as 3 over 1. I get 3 over 3, which is just equal to 1. So that means the dilated figure has that width of 1. And then for 9, I need to multiply it by 1/3. I get 9 over 3. And 9 divided by 3 is just 3. So the length of my new figure is 3. So now I just need to add all my sides up. 3 plus 3 is 6, plus 1 plus 1 gives me a perimeter of 8. Alright, so to review a different angle problem, we're looking for the measure of angle SVT. So first of all, I need to figure out what angle that is. So I start with where my S is, S, then I go to V, then I go to T. So I'm looking for this angle right here, which is represented by 2x minus 9. So that means in order to find the angle, I first have to find out what x is. Okay, so I know a triangle degrees adds up to 180. So if I know all 3 of these angles, I can add them up and set them equal to 180. I have 2 of them already represented, but I need this one right here. Well, I see that it's on a straight line with the 152, which means it's supplementary and adds up to 180. So I do 180 minus 152, and I get 28. So that means this angle in here, inside the triangle, is 28 degrees. Again, this 28 and 152 are on a straight line, so they add up to 180. So now I have all three angles. I'm going to set that equal to 180. So 4x minus 1, my first angle, plus 2x minus 9, my second angle, plus my third angle, which we know now is 28, all has to equal 180. From here I can combine like terms because the left side is really long. I have a positive 4x and a positive 2x, so that gives me 6x. I have a negative 1, a negative 9, and a positive 28. So I have a negative 1, a negative 9, and a positive 28. I'm going to combine my negatives. A negative 1 and a negative 9 is 10, negative. And then I have my positive 28. So negative 10 plus 28 is going to give me 18. They're different signs, so I subtract, and I have more positives with my 28, so I'm going to keep it positive. So 6x plus 18 all equals 180. From here, it's just a two-step equation. I'm going to subtract 18 from both sides, and I'm left with 6x equals 162. Divide both sides by 6, and I'm left with x equals 27. So let's go back to the question. It says, what's the measure of angle SVT? Again, we identified that angle SVT was this angle right here. That angle is not just x, so I am not done. Don't get tricked by this because this would be a multiple choice answer. So my angle SVT is represented by 2x minus 9. Now that I know x, I can plug that in. So it's instead of 2 times x, we're going to do 2 times 27 and then subtract 9. So 2 times 27 is 54 minus 9. So my angle SVT is 45 degrees.